Welcome back, students, to the chapter Laws of Motion. In this, we will be recapitulating what we have studied in earlier classes. That is the concepts of force, inertia, impulse, momentum, and Newton's laws of motion. We have discussed that force is an external cause in the form of a push or a pull which produces or tries to produce motion in a body at rest, or tries to stop a moving body, or tries to change the direction of motion of the body. In short, we can say force is that which changes the present state of an object. Coming to the concept of inertia, it is a property by virtue of it an object resists its change in its state of motion or rest. Heavier the body, more is the inertia, and lighter the body, lesser is the inertia. Coming to Newton's laws of motion, according to the first law, a body will remain in its state of rest or state of uniform motion unless and until an external force acts on it. The first law of motion is also known as law of inertia. According to the second law, the rate of change of momentum is directly proportional to the applied force, and it takes place in the direction of the force. That is, when an external force is applied to a body of constant mass, the force produces an acceleration which is directly proportional to this force. According to the third law, to every action there is an equal and opposite reaction. That is, when a body A exerts a force on another body B, the body B exerts an equal and opposite force on A. From the second law of motion, we have studied the equation for force as F is equivalent to ma, or F is equivalent to the rate of change of momentum dp by dt, where F is the net external force on the body and A is its acceleration. The SI unit of force is Newton. It is represented by capital N, and 1 Newton is equivalent to 1 kilogram meter per second square. So, in the second law, the concept of linear momentum is mentioned, which is the product of mass of the body and its velocity. Linear momentum is represented by the symbol small p. So, we can write P is equivalent to mv, where m is the mass of the body, v is the velocity of the body, and p its linear momentum. Momentum is a vector quantity and it has the same direction as that of velocity. The SI unit of momentum is kilogram meter per second. Coming to the concept of impulse, forces acting for short duration are called impulsive forces, and impulse is defined as the product of force and the small time interval for which it acts. Impulse is represented by capital I. I is equivalent to integral f dt, or force into time. Impulse of a force is a vector quantity and its SI unit is Newton meter. Impulse of a force for a given time is equal to the total change in momentum of the body during the given time. The impulse momentum theorem is given as impulse is equivalent to change in momentum, which is equivalent to P2 minus P1, where P2 is the final momentum and P1 is the initial momentum. Hope you have understood the basic concepts of force, inertia, momentum, impulse, and Newton's laws of motion. Thank you, dear students.